And that'll be a large part of your basis of your lab grade. Okay, we're going to, also I want you to do a PowerPoint or some sort of mixed media presentation. Some of you may wish to do a PowerPoint, most of you will, on some environmental thing, as if you were going to teach the class. And then a whole lot of you are. Because I've saved the last 6 lectures for student presentations. I can't have all of you presenting, but about 10% of you can. All right? Some of you will do PowerPoint, some of you will do, what's it called, Preza? You seen that format? Often students make movies instead. That's fine too. Film it, set out actors. I'll show you a great example when appropriate. All right, so that's a headwind. Some, it's like you were going to teach. And then I'll ask for volunteers to come actually do the presenting, and that material will be on the final exam. The presentations, the students that actually present, their presentation will not be graded. That would be unfair, because not everybody's going to do it. But everybody's PowerPoint or whatever presentation they do, their format, will be, of course, graded. Okay? Then we have one more thing. You can either go with me on a one-day field trip, and I haven't a clue where we're going yet. Or, if it's a conflict, I know I got student athletes that I've already heard from, you can do a term paper. And the guidelines are all on the syllabus. Okay? All right? So that's what this is all about. And the rest of it is all here. There's our schedule. If you have the book, there's the readings. There's the lab topics. Okay, so it's all there. And there you are. Okay, how does that look? All right, so as I've already indicated, this class is all about this planet, but today we're going to set the foundation about this planet. It sits in a remarkable world. We're quite used to the fact that we live on a planet. It's called Earth. We rotate around the sun. We have a solar system. And you know that this solar system is part of a constellation we call the Milky Way. So you got all that. So you've seen the Milky Way, perhaps. I hope you have. But did you know this Milky Way is hurling through space? Hurling through space. 136 million miles per second. Wow. Moving out. And out there in space are many, many other galaxies, like our Milky Way, and unlike. 600 billion of them and counting. Wow. And all those constellations are moving. And how are they moving? They're moving away from each other. Still, they're moving away. The universe is expanding. You might write that down. The universe is expanding. The Earth is not expanding. The solar system is not expanding. The Milky Way, the constellation is not expanding. The universe is. Wow, it's expanding. That's remarkable. And the first idea that was happening came from a fellow named Melvin Slipher, who was looking up in the sky. He found 12 other galaxies. You realize we're not alone. And then Hubble, in 1927, sitting on top of a mountain above Los Angeles, above Pasadena, on many cold nights, he found all 12 of those other constellations, and then more, total of 39. And now we know there's billions. And one thing about all those constellations, galaxies, what am I saying? Is that they all were reddish. All reddish. All reddish. What was that about? Why is every other galaxy, I don't mean constellation, galaxy, why is every galaxy out there, not constellation, every galaxy out there, we look at it, it's reddish. When we look at the light spectrum of stars, they're white. Many of them, some are red, some are blue. There's an average. But when we look at galaxies, like our Milky Way, they're all reddish, tilted to the red side. It's called the red shift. Red shift. The light is distorted. Red light is longer in wavelength. Something has stretched the wavelength that's coming back to us. Something has stretched that. Have you ever heard the sound of a horn of a car as it goes by you? Or the sound of a train horn as it goes by you? Have you heard that change of tone? Not the change of volume, but the change of tone? Yeah, yeah. Woo! Except I can't sing. Woo, you know. Woo! Well, you know what I mean? It changes. It's called the Doppler effect. Write it down. And you're doing a good thing. Some of you have computers out. Some of you are taking notes. All forms of engagement. I know many times, many lectures, everything in the lecture is up on a PowerPoint. No. We call that death by PowerPoint. Have you been there where you don't even need to go to class? Have you had classes like that? It's almost like a waste of time. Not this class. All right? My PowerPoint is just an outline. Rich in visuals, as you'll see, to carry the message. The lecture is coming from me. All right? Prompting you to get engaged. And if you can sit there and just mentally record, you're amazing. But most of you will need to take notes or type notes. And about the computers being open, I'm fine with that. But do not please go to Facebook or email while you're in my class. Why? Well, it's not respectful for the next person next to you. I mean, if you come in and open up your computer, and I'm sitting next to you, and suddenly you're taking notes, and then all of a sudden you're on Facebook, what am I going to do? I'm going to look at Facebook. I'm going to look at your Facebook page, or whoever you're scrolling, and suddenly I'm not listening to the lecture anymore. And suddenly I'm not getting that information. It just went right by me. And all of a sudden now we've got to have a midterm, and I don't have that information in my mind, and I'm going to get a grade that's lower. I'm going to suck at that exam, and then I don't get a very good grade in the course, and then my GPA sucks, and then I can't get into grad school, and then I go into the Army and I get shot because you opened up Facebook page. Okay. So you with me? All right. All right. So it's a remarkable thing. Origin of the universe and earth and life. This is a 2-lecture. So I will continue it on Thursday. And I was saying constellation a little bit. I meant galaxy. Constellations are just the arrangement of a few stars in space. But you probably figured out that I got into the wrong word. There are other galaxies. There's Andromeda, 2.5 million light years away. It's reddish. It's reddish. Wow, that's what's going on. It's moving away from us, everywhere in space. The universe is out there. Einstein, with his theory of relativity, was very bothered by his theory, because it argued for a beginning of time. But Einstein was an atheist. He says this just can't be right. There can't simply have been a creation where everything started. So he took out the part of his math that said that and published it. And then William D. Sitter, innocently, years later, in studying that work, said there's some missing math here. He put it back in, suggesting the requirement that there was a beginning of time. And so there we are, Melvin Slipher, 1930, 12 galaxies, not constellations, all right, beyond the Milky Way. This red ship, there it is. Hey, Melvin. And there's Einstein, 1917, doing it with math. It's all coming together at a time when the World War I was ongoing. William D. Sitter corrected it. And then at the top of the San Gabriel Mountains, Mount Wilson, this is where Edwin Hubble, worked many cold nights. And he found 39 more, all with that red color, all with that red ship. Not only that, the Hubble constant, not only that, he found that the ones that were the furthest away were moving the fastest, yeah. And the ones that were closer to us moving more slowly. That's huge. So the furthest ones were redder. What does that mean? Think about that. Undo it. Undo it. If you have all the trajectories, and we're not at the center, okay? If you take all those trajectories and move them back, they come back to the same place. But also, if you use those different velocities, the ones that are the furthest down have got to come back the fastest, don't they? Undo it all, and they come back not only to the same place, but they do so at the same time. 13.6 billion years. 13.6 billion years. What was there before that? We don't know. Wow. And so today we can go out into the heavens, get out beyond our atmosphere with the Hubble telescope. It's still out there. Wow. And we've also learned how to use ground-based telescopes and use math to correct for the atmosphere's distortion. So we're learning a lot. We have learned to peer into space where there are no stars. And then start looking. And look. And then there are stars. And jillions. And then those stars make up jillions, whatever a jillion is. Galaxies, not constellations. Wow. There they are. We can go out with those telescopes. Look, here's an area where there were no stars. And you're looking at light that is traveling from the edge of the universe. Those 13.5 billion light years away. When you look at a star at the night, oh, heavens, that light is not being emitted now. It just got here. It might be 2.5 billion years old, or 13.5 billion years old, and it's just getting here. Don't you see? When you could go into space, and we can do this now, and go to the very edges of the universe, you're looking at light at the time of creation. What's on the other side? It's like you're looking at the window of the face of God. I used to call this lecture God, Genesis, and Geology. I really haven't changed the lecture. One of my faculty colleagues says, you know, that's not proper. I said, really? You decide. You can count on this. There is an amazing design to everything about this planet. I'm not making a religious statement. There's an amazing design. And we're going there. And then, Arnold Penzias and Robert Wilson, working in the Bell Labs in New Jersey. That sound now has gone away from you. But if I had a sound sensor hanging in this room, the sound waves, would they not still be shaking? All right? Your televisions are a remarkable receiver. Do this. Perhaps with a glass of wine, if you wish. Turn out the lights in the room. Turn off, dim the TV all the way to zero. Unplug the cable. Unplug any antenna, whatever you got.